All right, let's talk about one of the biggest questions you face when building an AI machine. Do you go with a last-gen powerhouse that's a known quantity, or do you bet on a super-efficient new card? Today, we are putting two titans head-to-head in one of the most common face-offs for AI builders, the RTX 4070 versus the mighty RTX 3080.
And look, this isn't just some academic debate, right? This is a choice that developers, researchers, and hobbyists are making every single day. And I'll tell you right now, there's no single right answer. The best card for you really depends on what kind of AI work you're actually going to be doing.
So in the ring today, it's not just two cards, it's actually three. We've got the original 10GB 3080, we have its bigger, beefier 12GB sibling, and then we have the new kid on the block, the RTX 4070. And trust me, each one tells a very, very different story.
Okay, to really get what makes these cards tick, you gotta look under the hood. We have to start with their fundamental DNA. This is a classic battle of design philosophies, the raw, brute force of Ampere against the clever, surgical efficiency of Ada Lovelace.
And this right here really gets to the heart of it. Think of Ampere in the 3080 like a classic American muscle car. It is all about raw horsepower and a massive engine designed to move as much stuff as possible, as fast as possible. But Ada in the 4070, that's more like a modern, finely tuned race car. It's designed to be smarter, more agile, and use clever tricks like a huge cache to outmaneuver the competition.
So let's cut through all the marketing hype, okay? For AI, not all specs are created equal. We're going to zero in on the three battlegrounds that will absolutely make or break your performance. We're talking VRAM, memory bandwidth, and of course, the tensor cores.
First up, and this is the big one, folks, VRAM. This is totally non-negotiable. It's the gatekeeper. It determines if you can even load the AI model you want to run. It's like having a workbench. If your bench is too small, you can't even unroll the blueprints for your project, let alone build it.
And boom, right off the bat, you can see a clear divide. That 10GB 3080, well, for today's bigger models, it's starting to feel a little cramped, isn't it? The 12GB 3080 and the 4070 are really where you want to be, giving you that extra breathing room. But listen, having a big workbench isn't the whole story. How fast can you grab your tools and materials from across the room? That's memory bandwidth. And this is where things get really interesting.
Whoa, okay, look at this. This is that architectural difference in plain sight. The Ampere cards, especially that 12GB 3080, have an absolutely massive 12-lane superhighway for data. We're talking almost double the bandwidth of the 4070. That is the Ampere brute force approach in action.
So why should you care? Well, imagine your GPU's powerful cores are a team of world-class chefs. If the ingredients, the data, are stuck in rush-hour traffic on a two-lane road, those chefs are just standing around tapping their feet. That's a bottleneck. And that, right there, is how a brand new GPU can sometimes get smoked by an older one. All right, finally, let's talk about the actual brains of the operation, the specialized hardware that does all the heavy lifting for AI math, the tensor cores. These are the little wizards inside the GPU that make the magic happen.
Now, the 4070 obviously has the newer 4th-gen tensor cores. That's a plus. But its real secret weapon, its ace in the hole, is that enormous 36MB L2 cache. Think of it like a hyper-efficient assistant standing right next to the chefs, handing them every single ingredient the second they need it. It means they don't have to wait for deliveries from that slower main highway nearly as often. It just works smarter.
Okay, enough with the theory and specs. It's great and all, but what does this actually mean when you fire up an application and try to get some work done? Let's take this from theory to practice.
Let's start with a fan favorite, Stable Diffusion. This is the big one for artists, creators, anyone making images. This kind of work absolutely devours memory. So, which card comes out on top?
For something like Stable Diffusion, the verdict is actually pretty clear. The 12GB RTX 3080 is just the more comfortable choice. That killer combo of plenty of VRAM and that ultra-wide memory bus means you're going to hit fewer out-of-memory errors. You can push for higher resolutions and bigger batch sizes without the card breaking a sweat. The 4070 can hang for sure, but that narrower highway can sometimes feel like a real constraint.
Okay, but what about the other huge trend right now? Running your own large language models. We're talking Llama, Mistral, all those cool models you can run right on your own machine. What's the play here?
So for LLMs, the rules of the game change a bit. The number one absolute priority is just having enough VRAM to load the model in the first place. Capacity is king. So that immediately puts both the 12 gig 3080 and the 4070 on top and kind of pushes the 10 gig model to the side. Between those two, performance can honestly be a bit of a toss-up depending on the specific model you're running.
All right, let's bring it all home. We've dug into the architecture, we've broken down the key specs, and we've looked at how they perform in the real world. Time to put it all together and make the final call.
This table tells the entire story, doesn't it? Just look at those bolded numbers. The RTX 3080 12 gig is the undisputed king of memory bandwidth. It's not even close. But then your eyes drift over to the RTX 4070 and you see that massive L2 cache and whoa, look at that power number, 200 watts compared to 350. That's a huge difference. We're talking about real money on your electricity bill and a lot less heat being dumped into your room.
You know, the folks at Tom's Hardware really hit the nail on the head with this one. The whole point of the 4070 is that it gives you that 3080 class performance, but in a package that's just so much more civilized. It's smaller, it's cooler, and it sips power instead of guzzling it.
So here's the bottom line. If you're a power user, your workloads are super memory intensive, and frankly, you don't care about your power bill, then the 12 gigabyte 3080 is your brute force monster. Go for it. But if you value efficiency, if you want a modern architecture that runs cool and quiet, the RTX 4070 is the smarter, more balanced choice for most people. The 10 gig 3080, it's still capable, but it's just feeling a bit constrained by that VRAM limit these days.
And hey, if you really want to get into the weeds and see all of the charts and data, the source for this was a fantastic, detailed breakdown over at bestgpusforai.com. We've got the link right there for you, and we'll drop it in the description below. It is definitely worth a read.
And that leaves us with one final thing to chew on. As these AI models get bigger, smarter, and even more complex, what's going to matter more in the long run? The raw, brute force power of a massive data highway like Ampere's, or the intelligent, cache-heavy efficiency of an architecture like Ada? It's a fundamental question, and watching it play out is going to define the next generation of AI hardware.